Okay, so this video is going to be about logarithm rules, some common ones that we've used before, and then issues that people run into with them. So the three rules that we've talked about in class are these three. So if you take any log with any base, a particular base, and so like log base b of x, and we add it to log base b of y, we could say that equals log base b of x times y. I'll put those in parentheses. If you have a minus instead of a plus, then that's like dividing the x over y. And then the third rule is if you have log base b of x to some power, then that's the same thing as bringing that power down in front. And that rule we use quite a bit. So most students think, okay, great, I've got the rules, I can use them whenever I want, which is wrong. So these rules only apply if you know that x and y are both positive. Okay. And so here's why. I'll just look at the first example here. So I'm going to highlight this one. Okay. So if you think about x times y right here, we know that log base b of whatever I want, so I'm just going to put a box there, equals something. The stuff that goes inside the box has to be greater than 0. Greater than 0, because that's the domain of regular log. Greater than 0. So in this case, x times y has to be greater than 0. So that could happen if x and y were both positive, but it could also happen if x and y were both negative. And if x and y were both negative, then this x on this side and this y on this side would be negative numbers too. But that doesn't work because those aren't greater than 0. So that's why this rule only works if x and y are both positive numbers, if you already know that somehow. So some examples, if I said log of 3x, the question is, are you allowed to turn that into log of 3 plus log of x? So is that the same thing? And the answer is yes, because you know that 3x has to be positive. And since 3 is already positive, x has to be positive. So then you're allowed to go ahead and split it up. But if I said something like this, log of, I don't know, x squared, let's say, are you allowed to turn that into log x plus log x? And the answer there is you don't really know. So generally speaking, no, you're not allowed to. Because x squared, you know that x squared has to be positive. But that means that x could be a positive number, but it could also be a negative number. So as long as it's not 0, x squared is positive. So this means x could be negative. So then this part doesn't apply anymore. Okay? So let me give you a common mistake example that comes up. So let's see. I'll shrink all this stuff down. Let me get rid of this. So I'll make that smaller. Put that here. And here's a common mistake example. Okay, so let's say that the problem was to solve for x, and the problem was log, we'll just say base 10, so regular log here, of x squared equals 4. And so what a lot of students will do is they'll say, well, that's either log x plus log x, or they'll say, bring the power down in front, 2 log x equals 4, so then divide by 2, so log x equals 2. And so then if you use your conversion formula, then that's 10 squared equals x, so x is 100. Okay, well, let me put this all in a box and put a big X through it because that's no good. So the issue here is because of that X squared. You know, X squared has to be positive, but that means that X could be negative, because if you square a negative, you get a positive. So that means that that means that since X could be negative, let me write this over here. Since X could be negative, the rules on the left don't apply. So instead, we need a different way to solve this. So you see right here, we use that conversion idea of switching from logs to exponential form. So let's just do that right off the bat. So right off the bat, you could say 10 to the fourth equals x squared. 10 to the fourth is 10,000. And then when you take the square root, you get plus or minus 100. So that's the way that you don't lose out on any of your answers. Okay. Let's see, how long is this video? Let's see, is it recording? Yeah, okay. So example 8, we want to do the domain of these two functions, these two expressions. So first one, log of x times x plus 1. Okay, so right here, x times x plus 1, anything that we plug in a log, you know, has to be positive. So x times x plus 1 has to be greater than 0. And you can't just split that into, so x is bigger than 0 or x plus 1 is bigger than 0. They might both be negative. So instead, what we'll do is we'll make a sign chart for it. So this one, the zeros are pretty easy for it. It's going to be x equals 0 and x equals negative 1. So negative 1 and 0, those are my zeros. I'm going to plug into the left side, and those are my x values. So if I plugged in different test points, I'll tell you now, it's positive, then negative, then positive. So the domain is going to be negative infinity to negative 1 union 0 to infinity. Okay, so that's part A. Part B, I've got log x plus log x plus 1. And I need to check what the domain of this is. Well, I know that for the first term, x has to be greater than 0, and for the second term, x plus 1 has to be greater than 0, which means x has to be greater than negative 1. And I need both of these to be true. So if x has to be greater than negative 1 and x has to be greater than 0, you can sum that up just by saying x has to be greater than 0. So that would be 0 to infinity if you like interval notation better. One question that comes up is this. Can you say that if you started with B, if this was the original problem, log x plus log x plus 1, so this is the original problem, can you then turn this into log of x times x plus 1 using that rule above here, this rule, right? So some students kind of get freaked out about that. They don't know if they're allowed to or not. But you can. You can go from this to this. You just can't go backwards necessarily. Because if you think about it, x has to be positive, x plus 1 has to be positive. So that's like saying over here, x is positive and y is positive. So you're allowed to use this rule, right? So that's what we did. But if you went in reverse, the question now would be, if I started with this, can I go backwards? Well, no, you can't, because if you look at what values you're allowed to have here, you could get negatives in there for x. So that's not going to work. Okay, hope that helps. The next video is another common, it's a worked out example of how to solve for x using different situations, one where it's together, one where it's split up, and what the differences are. Okay, so I hope that helps.